Everyone. In this lesson, we're going to take a look at factoring by removing the greatest common factor. This is the first of a few different kinds of factoring we're going to be going over. Okay, so there's pretty much two steps to this. The first thing you want to do is find the greatest common factor between all of your terms. And then in order to remove that, what you're going to be doing is dividing that GCF by each of your terms individually. Now, we know the rules for dividing is you're just dividing by the coefficient and subtracting the exponent. So as I go through these questions, just keep that in mind. Okay, so we'll look at between 6 and 12. What's a common factor between 6 and 12? We could both divide those by 6. So I'm going to go ahead and write the common factor out here. Okay, so 6, and then I have an x to the third and x squared. We're going to use the smaller of those two. So we'll go with x squared. Okay, so that would be the common factor. And then now what we're going to do is whatever is left, or whatever, when we remove our 6x squared or divide by our 6x squared, whatever is left is going to stay inside the parentheses. Okay, so 6 divided by 6, that gives me 1. 3 minus 2 gives me x, or x to the first. $12 divided by 6 is going to give me 2. 2 minus 2 is 0, or x to the 0, so just 2. Okay, so the number out here, okay, the term out there is your greatest common factor, and everything that is left inside your parentheses is everything that is just left over. So what you're doing is pretty much this is what it works out to be is the reverse distributive property in the end. All right, let's take a look at another example. Okay, so we have 20, 15, and 10. I could divide all of those by 5. And then I have x to the fourth, x squared, and x to the sixth. The lowest one I see is x squared, so that's what I'm going to take out. So 5x squared, that's our GCF. And now we're going to go ahead and divide and subtract just like the rules for dividing by monomials. Okay, so 20 divided by 5, that's going to give me 4. X to the fourth minus x squared is x squared. Negative 15 divided by 5 is negative 3. X squared, that cancels out. 10 divided by 5 is 2. And then x to the sixth minus x squared is going to give me x to the fourth. Okay, again, there's our GCF. And that's what's left over. Okay, let's take a look at one more example. Okay, so we've got just multiple variables in this one. Same rules though, so between 6 and 8, what's the largest number they can both be divided by? We're going to go with 2. We have x squared and x to the first here, so x to the first is the lower one. And then I have y to the third and y to the second. I'm going to go with y to the second. That's the lowest one there, so that'll be what I'll be taking out. That's what they both have in common. 6 divided by 2, it's going to give me 3. X squared minus x to the first is just x. Y to the third minus y squared is going to give me y, so the first term is going to be 3xy. And now the second term, 8 divided by 2 is 4. X divided by x, or x to the first minus x to the first is 0. Y squared minus y squared, 0. So it's just going to be 3xy plus 4. There's my greatest common factor. And then what is left over in the parentheses is what it would be multiplied by. Okay, so again, this is pretty much just the reverse of the distributive property. Okay, so that's pretty much all there is to know as far as factoring by a greatest common factor. Again, you're removing the greatest common factor and then writing what's left in your parentheses.